Good afternoon, all, and thank you very much for the nice introduction, and thank you very much for having me here today. So today my talk is mainly based on the research we conducted at University of Sydney on bile acids as a potential additive for reduced crude protein broiler diets. In University of Sydney, we mainly worked on reduced crude protein diets as a sustainable approach for chicken meat production, and we are looking forward to add bile acid as a potential feed additive to overcome the issues associated with reduced crude protein diets, because we are facing some challenges at the moment with reduced crude protein diets, because some wheat-based reduced crude protein diets showed some negative impact on broiler chickens. Before moving into the research outcomes, I would like to talk about a little bit about bile acids, because most of all of you all know about the bile acid already, but I would like to make an initiation with a little bit of introduction about the bile and bile acids and bile salts. Bile is synthesis in liver and stored and concentrated in gallbladder. The releasing of bile acids from gallbladder or from the liver is caused by the hormonal effect, which the hormone calls cholecystokinin. Bile is a mixture of bile acids, bile salts, cholesterol, glycerides, phospholipids, bile pigments, amino acids, and water. These bile acids and bile salts are the main two components present in the bile, which facilitating fatty acid digestion. And the bile acid and bile salts are circulating between liver, in small intestine, as well as portal circulation. The circulation, the maintaining of the circulation is very important to facilitate efficient fat digestion. When looking at this circulation, we call it as enterohepatic circulation of bile acid. Cholesterol in the liver can convert it into the cholic acid or quinodiol, also known as quinodeoxycholic acid, which is converted cholesterol from the different enzymes, and these acids called as primary bile acids. So these primary bile acids can secreted directly to the small intestine, or sometimes it saturated or it concentrated in the gallbladder. Once these bile acids, the primary bile acids, move into the small intestine, they going forward to the distal ileum, and in distal ileum, these primary bile acids convert into the secondary bile acids, such as deoxycholic acid or lithocholic acid, by the activity of the microorganism present in the ileum. So most of these converted bile acid, the secondary bile acid, reabsorb the portal circulation, and approximately 5% of these secondary bile acid excreted to the outer environment with the fecal components. After this reabsorption of these secondary bile acids, they again go to the liver and conjugated with some of the amino acid called taurine or glycine, and they converted into the bile salts. These bile salts are very important for emulsification of the fat globules, because these bile salts contain heterophobic and the water loving and water dislike parts, which important to break down the fat globules into the small micelles. So at general, the maintaining this circulation is the most important thing, because the breakdown of this circulation will compromise or break down the circulation and reduce the fat digestion. In summary, as I mentioned before, primary bile acids, synthesis from the cholesterol, they later conjugated with the amino acids and converted to the bile salts, and these bile salts are important for the fat digestion. Also, this bile salts is important for cholesterol metabolism. As well as the maintaining of this circulation is controlled by the bile acid synthesis in the liver, as well as secretion of this bile acid from the fecal materials. So breaking down of this circulation by different conditions, such as disease condition in the intestine, as well as higher dietary fiber in the diet, also higher starch concentrations will break down the circulation and compromise the fat digestion. Now, when it comes to the reduced crude protein diets, in our university, we mainly work on these reduced crude protein diets. It has been found that reduction of reduced crude protein diets in broiler bring in environmental and bird welfare benefits, while they reduce in our reliance on soybean meal, because Australia is a country which is not produce soybean meal for the broiler production. Therefore, we have to import a lot of soybean meal. So our target is reducing inclusion of soybean meal and reduce the dietary crude protein. In Australia, wheat is the dominant feed grain used in broiler diets, and broilers' response to wheat-based reduced crude protein diets is poor than the maize-based and sorghum-based reduced crude protein diets. So we have a challenge in Australia. Why? Because in high concentration of soluble non-starch polysaccharide and rapidly digestible starch in wheat-based reduced crude protein diets have identified as important factors that associated with poor performance in broiler chicken offered reduced crude protein diets. Therefore, the connection between bile acid and reduced crude protein diet. So normally when we produce in low crude protein diets, we have to increase the wheat inclusion in diets, because we have to maintain the energy level, as well as to respond to the least cost diet formulation, we have to increase the wheat concentration in the diet. In that case, the starch level in the diet eventually increase, as well as non-starch polysaccharide concentration also will increase. Therefore, these factors will break down the circulation of bile acid in the enterohepatic circle. Therefore, the hypothesis of our study was birds offered reduced crude protein diets will benefit from bile acid supplementation. In this study, we used 840 broilers as the experimental units, and these broilers were in a flow pen, and each cage, each flow pen, we contain 35 birds per replicate. So this is the experimental design. So this, according to this design, we had 4 dietary treatments with 2 by 2 factorial arrangement, 2 dietary levels which has reduced crude protein diets as well as standard crude protein diet. So as you can see here, once the dietary crude protein reduced, you can see the wheat inclusion was increased. So this is the challenge we have with the reduced crude protein wheat-based diet, because these wheat bring in a lot of negative effect to the broilers. Looking forward to the growth performance, we haven't received any interaction effect from the crude protein level as well as the bile acid supplementation. But you can see here, there's a slight improvement. Slight improvement of feed conversion ratio with the bile acid supplementation, but it is not significant. However, as a main effect, bile acid supplementation improved the feed conversion ratio, but dietary crude protein reduction compromised the growth performance. When it comes to the nutrient digestibility, as a main effect, dietary bile acid supplementation improved the dry matter digestibility by 11.3%. and crude protein digestibility by 6.3%. But interestingly, fat digestibility was not affected by the dietary bile acid supplementation. Results highlight. As anticipated, dietary crude protein reduction reduced the body weight gain by 4.5% and increased the FCR by 1.6% regardless of bile acid supplementation. As well as dietary crude protein reduction decreased the fat digestibility by 2.4%. As a main effect, bile acid supplementation under the condition of this current study, regardless of crude protein level, improved the feed conversion ratio by 1% and improved the protein and dry matter digestibility as well as there were no effect on fat digestibility. Discussion points. As a main effect, dietary crude protein reduction compromised growth performance of broiler chickens offered diets based on wheat as anticipated. Always dietary bile acid did not enhance the growth performance in reduced crude protein diets, but as a main effect, dietary bile acid improved the growth performance. Interestingly, there was no impact from dietary bile acid on fat digestibility. This observation may indicate the maintenance of homeostasis of bile acid circulation within the enterohepatic circulation. Improved digestibility of crude protein and dietary bile acid supplementation groups may have stemmed from the reduced endogenous losses we observed in the dietary bile acid supplement group, thereby maintaining the enterohepatic circulation of bile acids as endogenous flows negatively impact apparent crude protein digestibility coefficient. In conclusion, dietary bile acid showed promise in broiler chickens, but in the normal crude protein diets. However, further research is needed to optimize the application in reduced crude protein diets because we observe a small trend that improvement of feed conversion ratio with the supplementation of dietary bile acid, but we need a little bit of fine-tuning of the diets and the other dietary application to observe this improved performance with the dietary bile acid supplementation. So what would be the future research potential? Examine the interactive effect of fat source and dietary bile acid supplementation on broiler growth performance because fat source can be affected and the interaction effect between the fat source and bile acid would be a fact, as well as investigate the influence of dietary bile acid in reduced crude protein diets with capped starch and protein ratio. This type of diets have less wheat but high fat, which is not facilitated in least cost formulation, but we are interested on looking at how the bile acid work with the high fat diet instead of high wheat diet. Finally, examine the synergism effect of dietary bile acid and other feed additives in reduced crude protein diets. So with that, I would like to thank you, my group. Importantly, main chief investigator of this research, Dr. Mehdi Tongayani, and my research supervisors, Dr. Sonia Liu and Dr. Peter Selle, and the lovely staff members of the Poultry Research Foundation and other co-authors. And also, thank you very much for your attention. Thank you.